The word problems we're going to start with are ones we've already done. It's just the solving is going to be just a little bit different and we're going to require a calculator to approximate our solutions. So number one, I'm going to ask you to find the width of a sidewalk surrounding a 6 meter, 6 meter by 10 meter pool, so that the area of the pool equals the area of the walk. I'm going to switch to graph paper here so that I can sketch this a little bit easier. You are welcome to do the same if you want to have an easier sense of how this looks and the kind of gridding that would be done out. So I'm going to draw this as a 6 by 10. Well, not quite 6 by 10 on the grid, but we're going to call this 6 by 10. That's the 6 by 10, and that is the pool. So we'll shade that blue to represent the water. Now, this is going to be surrounded by a walkway, and this walkway is of equal width. So this is a sidewalk. You're going to kind of see these things say sometimes uniform width or the same width throughout, or picture frames, if you kind of remember these from last semester. We're going to shade this yellow here just to represent the walkway. And this walkway has an unknown width that we're going to call x, so that the new width is 6, the original width plus 2x, and the new length is 10 plus 2x. And remember, that is because the width happens on all sides, 2 on the width and 2 on the length. Now, the key statement to make here, the key thing that we really need to make sure that you're getting is that it says right here, the area of the pool is equal to the area of the walk. So if I'm going to get these pieces out, I can say the area of the pool, is something given to us by the problem, that is 6 times 10, that is 60. Strictly speaking, it's 60 meters squared. The area of the walk is equal to the area of the yellow thing. That's the area of the hole minus the area of the pool. So the area of the hole is the 6 plus 2x times 10 plus 2x minus 60. So that is the area of the walk, and it says the area of the walk is equal to the area of the pool. That should help us set up our equation. 6 plus 2x times 10 plus 2x minus 60 equals 60. So if I multiply this whole thing out, I get 4x squared plus 12 plus 20, so plus 32x plus 60 minus 60 equals 60. Well, I can cross those out and move everything over to one side, and I would get 4x squared plus 32x minus 60 equals 0. Clearly, I can see both the left and right side are divisible by 4, so I get x squared plus 8x minus 15 is equal to 0. 15 will factor into 5 and 3, which looks like it would get me to 8, but the signs are wrong. So I actually need to complete the square on this or do quadratic formula. Just to practice, I'm going to complete the square. X squared plus 8x. We're going to add a 16, because that's half of 8 squared, equals 15 plus 16. So now that I have that, this is going to factor into x plus 4, quantity squared, equals 31. Or x plus 4 is equal to plus or minus the square root of 31, which is an irrational number, so we're going to leave it as an imperfect square, or as a square root. And I get x is equal to, subtract 4 from both sides, negative 4 plus or minus root 31. Now, root 31 is going to be a little bit more than root 5, or root 25, so I'm just going to take the positive one. I know that means x is actually equal to negative 4 plus root 31, and if I plug that in a calculator, I get about 1.57 meters. So the width of the walkway is 1.57 meters. The second type of problem we're going to encounter is I'm going to say that the volume of a rectangular box and the rectangular box is made by cutting 4 centimeter squares from the corners of a rectangular piece of cardboard the volume of the rectangular box made by cutting the rectangular piece of box from the, by cutting the squares from the corners of the rectangular piece of box of cardboard, I can't talk, is 136 centimeters cubed. We'll say the base has a perimeter of 24 centimeters. Oops, can't spell. And we want to know what the dimensions are. Find the dimensions of the box. So the first thing to note about this box is that we have a box that we're forming by cutting corners off. So I have something like this, where I am actually then going to chop off a corner here, 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 and here. And when I do that, what I get is something that looks more like this. So I'm chopping off the corners, and those corners that I chopped off were 4 centimeters tall. So we can do a subtraction if you want, but let's actually go ahead and then do the little dot dot dots here and fold this box upwards to try to get a sense of what these dimensions are. So we create this, fold it upwards, and I get something that looks like this, where the top is open. Sorry, hang on, let me change that back to stroke eraser with that, and let's go back to my this. There we go. And we'll do a little dot 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 like that. So I'm going to call this the length, call this the width, and the height. I know this was 4 on all sides, so my height here is 4. And let's create a volume equation and any other equations we can do. So it says the volume is 136. Volume is length times width times height. 4LW is 136. And then it says the base has a perimeter of 24 centimeters. Perimeter is 2 L's and 2 W's, and that is 24. And we have a system of 2 equations with 2 unknowns. Once we have the equations, I don't need to look at the figure anymore, but we're going to simplify both of those equations. The first one, I can divide both sides by 4. 136 divided by 4 is 34. The second one, I can divide both sides by a 2. L plus W is 12. This makes it a lot simpler. I'm going to do a substitution and solve this second one. 12 minus L is equal to W. Go ahead and plug that in here. So I get L times 12 minus L is equal to 34. This means that I need to multiply everything out and see if I can refactor it or use another method. So 12L minus L squared is equal to 34, or L squared minus 12L plus 34 is equal to 0. This also does not factor, so we need to solve by the quadratic formula or completing the square. I'm going to complete the square. L squared minus 12L plus, I want to add a 36 and make that equal to negative 34 plus that same 36. And that will give me L minus 6 quantity squared and is equal to 2. And I get L minus 6 is equal to plus or minus root 2, or L is equal to 6 plus or minus root 2. we kind of need to play around with our options here because I've got two possible lengths and both of them will work. The square root of 2 is about 1.41. That's one that you guys should have an idea of. So I know that both lengths are possible. So we're going to say if L is equal to 6 plus root 2, I need to find out what W is. W is equal to 12 minus L, so 12 minus 6 minus root 2. If L is equal to 6 plus root 2, W is equal to 6 minus root 2. So that's fine. They're interchangeable. I mean, we get if L is one, then W is the other. So that takes care of our two possibilities. We want to approximate those in a calculator, so we get about 7.41 for this and about 4.59 for that. So if I ask it to 2 decimal places, we would say the dimensions are 7.41 centimeters by 4.59 centimeters, and I have to include the height of the box by 4 centimeters. That was given, but that is part of the solution. So that's it. This is supposed to act as a big review of the previous ones. These do not factor, and remember that for your homework, at least this is in 2019, your homework is this. And please do the problems, not the written part. The problems 2, 3, 5 through 8, all 12 or 13, 14, and you are for all of these you're going to state the exact and the approximate answers. And approximates we're going to do to 2 decimal places, round to the nearest hundredth. And that's all.